All right, from today, this week, I think we're going to focus a little bit more on the actual methodology of software development. And I did mention a very popular approach called Agile development. And then I think today, or maybe also tomorrow, on Thursday, we'll talk more about this concept. I actually do realize that normally we play a game in today's class, but I don't think there is a way to play this game anymore with a virtual classroom. It's literally impossible. So I think I'm going to skip that game. I will talk about the concept. Okay. So we normally use this game to introduce Scrum. All right. So let me actually talk about this background. What is Scrum? Why are we needing this? All right. So this is more about the software development approach, methods, or way we organize our teams. To understand Agile or Scrum, all right? So we need to understand the very classical and traditional software development approach, which is called a waterfall development approach. All right, so you might be able to find a different version of the graphs, but it's all similar. Maybe they have slightly different stages. Like here, I use this 5-stage graph here, from requirements to design to implementation to verification, eventually maintenance. All right. This is how we build software in a traditional way. Really easy and straightforward to understand. To build a software, we need to collect requirements. And after that, we need to do a lot of design, think about how we're going to code it, what is the structure, what is the relationship. And then from there, I'm going to write all my code and have it done. And afterwards, I need to run a lot of tests. If I verify everything, I'm able to deliver it to the customers, and I'll do it. But after that, I'll still need to do a lot of maintenance. Particularly today, if your application or project is related with internet or mobile or servers, so you always need to do some kind of maintenance depending on how much traffic you get, right? So this is a really easy way to develop a software, right? It's very similar to most of the project. Whatever project you're trying to do, it doesn't have to be a computer science project. You always need to go through this. What's your goal? What's your requirement? And then how are you going to do it? And then let's do it. After you do it, verify it, and then to do some maintenance. All right. So it's pretty reasonable that most time we were following this approach. All right. However, there is really some of the big problems of this approach. From the early days in the 60s and 70s, 80s, these are pretty much the major approach people are using. But from early 90s, late 80s, and then a lot of people do find that there are some kind of issues when you are following this kind of approach. All right, because when you look at a graph, even though the steps looks very common sense, right? So this is basically how we attack the problems in most of the fields, as I explained. But every step, it looks really nice, but there's a lot of issues in it that you cannot really do it perfectly or completely. So that's going to bring some issues to the later stages. All right. So here you need to understand one thing about the waterfall approach is normally, let's say if I have 1 year time to develop a project, all right, and then to follow the waterfall approach, okay, so you need to finish your requirements completely and read the documentation, know exactly what you want, right? Probably that state will take about 1 month. After that, we need to do the design. Now this design, we're talking about a very detailed design. Maybe draw some UML diagrams. Maybe you need to write a lot of documentation. You need to kind of draw all the different architecture diagrams for a system. And the design probably also can take 1 or 2 months. All right, so that's about 3 months. And then you get to the coding. And the coding part, you can't spend all the time on coding because you still need to test and maintain your software. So probably, you spend half a year to actually do the implementation work. Everybody work hard, just write the code, get it done. And that's total for 9 months. And after that, you spend 1 or 2 months to test and verify your software, okay, because that's a lot of code. And then if everything works, then you use the remaining 1 month to deploy it and then to deliver to customer, right? So this one, it sounds really good, but in reality, there's so much potential risk and issues that it may not work very well. And some of the issues, particularly as this figure shows, I kind of explained this one point. Remember that, okay, so when customers are talking about some kind of product they want, maybe that's what they mentioned. But when the software team started building and design it, that's what it looks like. And after all this work and then you deliver it, you find out that the customer really need something totally different. Okay, so this one shows a lot of gaps between the two parties, the customer and the developer. All right, and there is always this kind of a dramatic mismatch between the two. Now you might feel this picture looks very funny. It is not funny at all. You might feel that this is crazy. I will never design something based on this, right? But in reality, I just have seen so many. I don't have that much experience in terms of development, but it's already enough for me to see so many this kind of scenarios where the developer just totally thought about something else from a technical point of view that's not really usable by the users. And also I have seen so many times that eventually we deliver what they describe like here. After 1 day or even 1 hour, the customer started to use that one, they immediately start to tell you, oh, I don't think this button should work this way. They actually need to do this, that, and then I need this page to show up this one here and this one here. But that's when the project is done and they came back to you and asked you to make some changes. All right. So that's kind of really sucks. So that's why if you see this kind of um, approach, if you do this kind of way, even though you might think you have a very decent and solid requirement design, and then you do the coding and testing, the risk actually sits after you do all the testing. Because at this point, remember I told you, it's already like a year past. You spend all the year time on this project, then you hope the customer will like it and start to use it. But at that time, and then customer told you, oh, actually, you know what, I'm actually needing something like this. Or you actually doing something like this and it's not what they want. All right. So either way, it's really sucks. All right. So this one does happen so frequently in the past period of time. And then if this is just a 1 week project, it's really not a big deal. And I will just redo it. That's okay. Spend another week. And maybe I will spend less time because I'm already familiar with all the concept. But when this project goes over half year, 1 year, or sometimes multiple years, and at the end you deliver it, and then they told you, okay, doesn't work, and that's going to be a big issue. All right, and then waste all the time and money. And normally for a system like in that scale, you just cannot go back to redo it. All right, so these are the main issue with the waterfall development approach. Okay, you should never risk yourself to put all your time just to code without any kind of control on whether that's right to the customer or not. Right. So based on this problem, people were thinking about how do we solve the issue. Right. And then if as you see that the major issue comes from this understanding or knowledge gap between the domain expert, the users, and the developers, right? So we as developers, we understand programming, we understand data structure algorithm, we know what to do, how to build it, whether it's feasible to build or not. But then we do not know the domain knowledge. All right, one day you will see what I'm talking about today. When you got a project going on with a certain customer, all right, maybe come from, I done some project with some of the travel agencies, and I done some project with some of the like cultural based type of organizations. And you might think that concept is really simple, but very quickly they can give you a very overwhelming amount of the concept and little issues that is just beyond our knowledge. And also you don't find it very interesting to learn all of those. Think about in that case, when you develop something, the feature, the workflow definitely will not be perfect based on what the customers are looking for. But on the other hand, the customer knows exactly what they want, but they just don't know how to code. And that seems to be a much more bigger challenge. So that's why when these two parties work together, you really need to control the risk. And the people find the ultimate way to solve this problem is not really difficult. Instead of waiting for 1 year to see it at here, let's see it as early as we can, right? If you have 12 months to develop it, let's not wait for 11 like November to see it. After January, I want to see something. And then since then, every month or even every 2 weeks, show me something so that I can give you some feedback. Instead of doing this whole year cycle, we want to break it down into smaller cycles so that the customer can see it more often, can give you the feedback sooner, so that you don't have to spend all the year round time on the wrong thing. All right. And then you might come to this question, okay, so if we can deliver in 1 month, why do we still plan it for 12 months, right? So how could we get everything done in 1 month based on the project that we budgeted for a year? Well, the answer is during the first month, at the end of the first month, we do not expect you to finish all the features, all the functionalities. You only need to deliver, for example, 10% of the features, since this is a year project. But that's okay. Even that 10%, I can give the customers quite a lot of view, and they can give a lot of good feedback and make sure that you are on the track. So if you can do this kind of more frequent delivery and checking, and then your software will be much safer. All right. So that's what we call Agile development. That's why the Agile is the name. So we want to be faster. Okay, we want to be swift. We want to be very flexible. All right. So as I mentioned, the core fundamental idea about this Agile development is that I want to break this long, big cycle into smaller cycles. And every cycle could be anytime from 1 to 4 weeks. That's very typical. All right. 2 weeks or 3 weeks are more common. And sometimes you see 1 week or 4 weeks. All right. And then I'm going to basically decide what I want to work on for each cycle, right? Because the time is a limit. I can't finish all the system, but I'm going to start from the most important ones, the highest priority, and that's to start work on that because I need to deliver those first. So before every single cycle, we need to plan and decide what we want to work on, and then we pick those features as our plan, and then we start our cycle. During that cycle, all the developers start to work together and to make the changes and try to finish the list on time. And after that, we will actually deliver the version to the customer, whether it's a demo or maybe I can just deploy that, they can start to use it right away. And then I can start to receive feedback and then I can do some review. At the same time, I'm going to move to the next cycle with another 2 or 3 or 4 weeks. And at that time, I will need to pick some other features here to work on and then do this kind of iterations one after another. All right. So that is called Agile development. All right. Really simple. Really nothing complicated to understand or nothing no hard series. It's a very practical approach for a team to think about how do they plan things and then move forward. Right. So this kind of also summarizes the idea, right? So from every cycle, okay, you're gonna do a complete development, including all the design requirements, including your coding for sure, including to testing everything, and also eventually release your software and deploy it. All right, so that is how the Agile development works. And then you come back to the next cycle, but remember every cycle you do a complete development process, including testing and everything. Ideally, you should actually release your version. And think about every day when you're using your app, right? Most of us have the App Store, the update enabled automatically. So every day in the morning, probably when you get up, you probably didn't realize that your app got updated. You didn't realize that because it's not really a major change. They probably just fix one bug, maybe added some new button, new functionality, or just simply change a little bit UI. Very minor change that, but you can still notice. So that's how they do this kind of iteration-based development. So every little cycle, they have some goals, and then they will just roll out that feature to the customer at the end, and then keep going with the next cycle. However, nowadays, no company will actually spend whole year just work on something and then release at the end of the year. That's very risky because they never know at that time, maybe there's some other competitor already there, or maybe that feature is really not useful anymore. Okay, so using the cycles to handle this issue is actually very effective. Okay, because that gives you more communications and also give you much earlier communications so that you can actually get rid of this potential result as soon as you can. Right. So that is the whole idea about Agile development. Any questions so far? All right, there's no math, no series, just some kind of practice. All right. Normally in this course, we actually ask you to play this what is the name, like a point ball game. I think something like that. Basic idea is actually I'm going to bring some ping pong balls. Normally they play with tennis, but it's too expensive to get too many tennis. I just bought very cheap ping pong balls from Amazon. I bring it to classroom, and then I just asked everyone to play this together. So basically the whole class will be a team, okay? You guys are all in the same team, and then we just ask you to pass the ball as many as possible. And then when you pass the ball, there must be some kind of air time. So you can't just directly hand it over to another person's hand. You have to throw it, a little bit throw it. But it doesn't matter how far you throw it, but it had to be having some kind of air time. And then, but then you cannot pass it to your direct neighbor. We just want to make it a little bit more difficult, okay? It could be the one that facing you, or it could be the one next to your neighbor, okay? And then, so you pass the ball, every ball, we want to make sure everybody actually touch it at least once. And then after a round of passing, the ball will come back to the original person. All right. At that time, we finish one ball passing, and then you get 1 point. All right. So once I give the rule, I will ask everyone to just try to get a formation, line up, and then have people to to start this game. And what I will do is every time we give you 2 minutes for preparation, and then you guys need to tell us how many balls you think you can pass. And then we give you 3 minutes to actually try to passing it. And then we count how many you pass eventually to see if there is a mismatch between the actual numbers you got and then the goal you set. So after that, you guys discuss and see how to improve, and then provide another goal and another iteration. So keep going, and then so that we want to see if you guys can improve this one consistently, get more and more balls passed, and then you set the goals more and more accurate. All right. So this is how the what's called a point ball pointing game. All right. So let me see if I can find a video about this one. Right. Ball point game. All right, let's try that. All right, try this one. Let me reshare, make sure you can hear the sound.
3, 2, 1, game on!
Right, so basically, as you play, we try to get you train you the concept of iterations. So in the beginning of each round, then we ask you to predict again how many balls you can pass. You write it down, and then you do it. So at the end, if you see that there's a big gap between the goal and the actual balls you pass, then you guys need to discuss and see how to improve. But over the time, we want to see that the goal you set actually increases, and also the accuracy also increases. Because this basic is similar to when you start to do the development. I mentioned that you need to pick some of the tasks and make some plans. And we don't want you to make a crazy plan that nobody can really deliver. And also we don't want to make a plan that's too easy for everyone to finish within a short period of time. So, but also after every iteration, we want to make sure that the team can produce maybe a little bit more feature each time, get more and more efficient. So that all need a lot of teamwork, and then every team need to figure out their own best approach and best practice.
Três, dois, go! Três, dois, começa!
The gym comments I heard, lock the machine and fade the balls faster.
Go!
Yeah, anyway, as you can see, the last approach here, for sure, is definitely much more efficient. So we tried this one in our classrooms. Not every time our students can figure out the most efficient approach. Sometimes it goes better, sometimes it's even goes worse. All right, so I can show you some of the data here. When we were playing this one, this is last year. Okay, let me actually go through the early ones. I actually kept the slide. So in 2015, as you can see, they estimate first round, they said they can do 60 goals, 60 balls, and then they actually only passed 5 on the first round. And then after that, they got very like conservative. They said, well, we're going to do 20. And then they actually did 17, and then 30, and they started better, 45. And then this is around there where they change the approach, but find out the approach doesn't work, right? It goes even bad. And then they keep the same goal and still didn't make it. And then eventually they somehow figure out the best approach. And then there was a jump, and then they actually deliver a lot of goals. Okay, so you can kind of start to see that they adjust all the plans. The efficiency got also changed. And this is another round. Also at the end, they delivered much more. And then this is the summer. Also, they only use 5 rounds here to get to over 100 points. And then 2016, 17, and then in the latest year, like 18, right here. So they played this for 6 rounds, okay, and then only got 20. I think last year wasn't very good either. And then last year we did also 6 rounds, and then we got 34, and much less than before. Can anyone guess why this one is so much worse than the early classes? Just based on your understanding about this game. there was a dramatic change. The early years, the number were much higher than recent years. Yeah, exactly. So we got a lot more students. And then in this years, we only had like 35 students, where recent year we always have this larger class, 80, 70 students, right? It's just, I'm not really saying that the number of students will essentially lower the actual time you need to finish the task. The main issue is it's much harder to coordinate, to communicate with a bigger team, and to get agreement, and also to execute things. So that's why, this is something about software development. Most of the time, when you work on a project, the smaller teams are always going to be more efficient than a bigger team. And this is something very special about the software development. And there is a very famous quote: adding manpower to a software project. All right, it's not going to help. Let me find out that. All right, so here, there's a book. You can take a look at this one. It's written by a very famous author in software engineering. And then he shared this most important rule, which is, where it says, yeah, right here. So adding manpower to a late software project makes it later, right? So that's the idea from this book. It's very true. Think about if you have a lot of bugs and you add a new developer, they can't really start to make changes right away. They need to spend so much time to understand that you need to help them understand. And then they start to make some new changes, then that maybe cause new problems, right? But a lot of other projects, adding manpower will help. Again, the best example would be building a house in a construction site. I think getting more manpower will help anyway, right? And so that's really something very special about software development, right? Kenny, what do you mean it's different? You mean the cover, the version? Oh, okay, yeah. So yeah, it's a very famous book in software engineering. All right. So anyway, guys, so here we can't play the game, but I just want to give you this idea that we are trying to use this game to show you the idea of iterations. Okay, the iterations is the core fundamental concept of Agile development. It's really easy, I already explained. Okay, previously, we give you 1 year, you do 5 steps, one after another. Now I give you 1 year, you break it down into 12 months, and every month you do this 5 step, one after another. That's it, that's called Agile. All right, it looks really simple, but it's so significant in software development field because it, effectively lower the risk of all the development and deliverables. Right? So that's why these days every single company, big companies, are still using Agile development. I think 95% of projects using Agile development, but I'm not saying that nobody using this one. There are still teams that using this one. I gave you an example. 2 years ago, there was a master's student from JPL, and then he did tell me that their team are still using the waterfall approach. In my opinion, that also makes sense because I think when you work on a project like some of the big project for JPL, some of this Mars project, since those projects are super complicated, it's huge, and you really need to do very, very detailed and then sophisticated requirement design before you write any code. And once you finish all the code, you need to do a really complete testing again and again before you can really launch your your satellite or rocket, right? So that's actually very special. Also for JPL, don't forget that this kind of project, they really don't have much competitions, right? So they're funded by the government, and then not many companies, really, countries can do that. So they just need to be safe and then be reliable. But that's why they using waterfall. It still makes sense. They don't have customer. They're their own customer, right? But then if you're talking about the internet company and app, this approach is not going to work at all. Okay, you need a much faster iterations to move forward. All right. So that's kind of a quick overview about Agile development, why we need it, and then what is the core concept. Now this part of the slides, after the game, we normally just give you just a little bit more concept of using the Agile development. Okay, let me go through this again. This is a different version of the waterfall model. This is proposed in the 70s. As you can see, really early. It was very successful. It's just because later on, when the software become more complicated, this approach started to show a lot of the drawbacks. All right, but again, from the requirements, you go specification, design, implementation, and then integration, maintenance, similar. It's just different type of, sometimes more detailed stages. All right. Again, so the problem with this approach is it doesn't really deal with this issues very well, and then that's why we propose to use Agile development approach. For Agile, we break down your big cycle into smaller cycles. As I mentioned, every cycle we call it a sprint. Okay, that's a term, and every team can decide how many weeks are in the sprint, but normally it's 1 to 4 weeks. Right. When I was in Amazon, some of the bigger teams, they use 3 weeks sprint. Some smaller team, they use 2 week sprint. If this is a new product, they actually use 1 week sprint because they can write more code and do more features within 1 week. So they will just do one week sprint. Yeah, and then the daily Scrum meeting, we'll talk more about that one. That has nothing to do with the duration of the sprint, but it's a very important activity. Some important meeting that happens every day when you are using the Agile development. Yeah, so it's really important. Yeah, so we'll talk more about that maybe next time. And then very good. Yeah, it looks like a lot of you have been doing the Scrum and being the Scrum Master. Very good. Okay. But anyway, so the duration of a sprint is normally 2 to 4 weeks. For example, in your project, you could organize some kind of sprint with the team together. I would probably suggest a 1 week sprint. Okay, so make sure every week we deliver something, and then and also what to do. No, this is the same concept I mentioned, right? So let's say this here they call it a backlog. So basically, this one here contains all the features you want to finish for your project, right? So you need to write down the whole feature. Of course, you can keep adding things constantly during the whole development project. You find new thing to add, you find bugs to fix. So this one will be just like a warehouse of everything you want to implement. But you can't really implement everything within one sprint. So every sprint, you pick up some tasks and move it here to this goal for this sprint, right? And this part here, we'll talk more about it. Is you need to decide how which one to pick and how many do you pick. And once the goal is set, the developer will get into the cycle and start to do all this kind of development work. After that, we come back here, we'll finish, we deliver, and then we'll also do some kind of discussion to review, make sure everything works. All right, so that's, again, the same idea, but just different presentation. So these are the key members in a team, or in a typical software development team. So you got a product owner, and that's normally, I would say, the manager or product manager, who is really the one responsible for giving this to the customers, delivering this one, and communicating with the customers. All right, and then these are our development team, and then most of the members are in the development team. Then there are different roles. Maybe they handle front end, back end database, but also we need to have a Scrum Master, and then Hansi just mentioned about he being Scrum Master. So Scrum Master, basically, you need to control all the sprint meetings, organize and lead everyone to pick all the tasks and make sure everything got finished on time, and also lead everyone to do some discussions, improvement. So Scrum Master is kind of like a manager for the whole team by following all the Scrum practice. All right. So sometimes Scrum Master is your development manager, but more common, I think Scrum Master will be one of the developers. Okay. In many teams, people take turns to become a Scrum Master so that everyone can get the opportunity to kind of know what's going on and then to do some kind of a leadership type of work. All right. So that's a very typical setup. All right. And then, yeah, what's you don't like the daily Scrum meeting? it's really important. Okay, I'll talk about that next time. And then yeah, so again, this one shows the same thing. So for every cycle, all right, we do the complete development, including the plan, requirements, design, writing the code, and then test it, demo, show it, and deliver it, and also to inspect, to review everything. All right. So these are the steps that you need to finish within that one sprint, whether it's 1 week or 4 weeks, but then you're supposed to do everything completely. That's why planning how many features you want to do, that's important. You don't want to do something that you can't have the time to test and deliver. We want to make sure that you pick 2 or 3 features, but then you plan it well, implement it well, and also, test it and deliver it to the customers. All right, so that's kind of some of the basic concepts. All right, so when we are following the Agile development approach, when you are talking about these features and backlogs, what to work on, right? In the old days, we write this very formal documentation about requirements, and you can imagine it's just like some kind of a paper. I give you different sections. Every section I give you bullets to talk about what I want to make. Nowadays, people don't write this kind of document anymore because it's very boring to read and it doesn't give you a lot of information. So most of these features and backlogs are created using this kind of a user story type approach, right? So this is a very common practice in the industry. So what, for example, we're going to build a system and all the team now have ideas and you will know what the feature you want to do. But how do we summarize those features, right? So we summarize those as user stories. This is the format of user story. So you would say that as somebody, I want to do what so that I can reach some kind of goal, right? So this is a very typical way to summarize the feature. So for example, as an admin, I want to download the page reviews as a CSV file so that I can graph them in Excel. All right. So this one really shows a lot of information. It shows who is going to use the feature as admin and what the feature is going to look like. You're going to basically be able to download some CSV file. Also, it points why people need that and how people are going to use that because they will need to see and visualize that one in Excel, right? So this is a very concise way to summarize what we want to build. And as you can see, this one covers both parties, developers and the users, so that the developers can better understand their requirements and they will know why they need to make it and how can they ensure a good user experience, right? So writing down the user story is a pretty important skill as a professional developer, okay? So from your team, as you start to plan your development, you should actually start to try to follow the user stories and then plan your tests, okay? So we'll give you more specific guidance on what to do for your team project. I think everyone need to start to follow some kind of a tool to document all of this and then really follow the Agile practice. So we'll talk about later. Today, I will just give you more about this concepts here, all right? And then once you get all the tasks here, and you need to pick which ones to work on first, all right? So the rule here is very simple. You go with the important ones first, always prioritize that first. But there are so many different things here. At this point, you will just need to get more inputs from the team. The inputs could be from developers, but more importantly, probably coming from the product managers because they deal with the customers. And also, as explained to you earlier in the course, if you can directly talk to a customer and get their feedback, that's always preferred. Okay, so again, during this process, there are always some kind of arguments and discussions, but then eventually, don't forget about the rule. It's all about the customers. Okay, it's really not about boss or director what they say. All right. So this one again, this rule sounds really simple, but in reality, I can tell you, it's very difficult to follow that 100%. I have seen so many, a lot of times. Okay, I sometimes talk to some of these business owners. All right, so they obviously are very successful in their domain, But whenever they talk about the software, everything, they are very kind of somehow kind of arrogant. Okay, so they will criticize, oh, you know what, this software shouldn't be doing this way. This is bad, and they should do this and this and that. Eventually, they didn't realize that what the software should be is based on what the customer need to have. It's not really not about how you are saying it. And then, but then a lot of the bosses will probably make that kind of mistake. Right, so at the end, it's all like customer based. That's why I explained that Amazon is really successful in this field because they really mean it. Okay, so when they say customer, they really try to do it with the customer based approach. All right, so that's something to keep in mind. How do you prioritize? It's all about what the user need most. All right. So once you get the list, and then you know the priority list, then you need to pick, do I work on 1 feature or 3 feature or 5 feature, right? So we need some estimate. And then the way we estimate it is to see how long this feature is going to take and then how many people do we have in the team, right? So that will involve a really important step where you need to estimate for every feature how long it's going to take. So for example, right, this GUI is going to take 2 hours. This one takes 3 hours. This one needs to finish 2 hours. And then we look at our member. Okay, we got 3 members in this week to work on these things, and then they have a total of X amount of hours. So looks like we can get 8 features done based on these numbers, and then let's plan for 8 features. All right. So there's just some very simple math here, but then the really challenging part is how do we estimate the hours? Because the working hour is the fixed, right? Everybody got 8 hours per day. That's easy. And then you got a certain number of developers. That's also easy. But the really challenging thing is how can you put the number of hours for each single task, right? So that will involve some kind of discussions. All right. You really don't want to give the wrong hour. If this task is really challenging, you only put 2 hours, then that's going to mess up the whole plan. But at the same time, you don't want to, for this 4-hour task, then you don't want to, make a mistake that this is really something simple that then you're going to waste all the resource and time, right? So I'm very curious, like in some of you who mentioned you've done some Scrum, have you done this kind of estimation on the hours for the tasks? How did you guys actually figure out the numbers? Hansi, do you have anything to comment? Like how do you estimate the task hours? Or did you guys do this? Exactly. So, but then the question is, how do we estimate the time, Nick? So you create these features, user story, whatever task it is. Who actually estimate the time? Right. So it's like somebody is deciding it, like Scrum Master. You say, oh, you're a junior developer, probably you need, longer time. So I'll just assign it to you, and then you finish that within this week. Is that how it works? Yeah, by experience. But who decided? Is one person decided, and or who is the experienced guy? Right. Yeah. Yeah, sounds good. So formally, I think this whole process should be done as a team together. It shouldn't be based on one person. I kind of get what you're saying, Nick. So it sounds like you guys are doing some kind of a very like a, I won't call it very strict like rules on this one. It's more based on the developer experience and the importance of the task and who might fit this one better, and just to get some kind of estimate. It's that also very common. But then the very formal way is everybody need to, first of all, we prioritize the list of tasks, and secondly, we need to actually make agreement on the number of hours. This hour shouldn't be based on the experience. Okay, but of course that requires your team have a decent level of development skills. But sometimes if it's intern, maybe it's not really counted. Some intern normally have some other different task, maybe more independent. They're not going to join in this kind of a feature-based, this hour-based type kind of tasks. But the best practice is we need to get these numbers first without considering who's going to work on that. All right. And then we assign it to people. All right. So here, I think that's why I was asking, the most challenging part here is how can you figure out these numbers? Okay. Because you might think it's very difficult, or I think this is very easy, right? So a lot of teams actually do this. I don't know if you ever experienced. They actually just ask everyone to vote. And then when you vote, obviously you don't want to say it one after another. If one senior guy said it's 1 hour and nobody else is going to say it's 4 hours, right? So everybody just show up something same time, right? They use poker card, they use this number card, and tell them, what's the number you think that's worth the hours, and how much time it's going to take, right? Or sometimes they just show the fingers together, and to see if it is something that people will agree on. The reason this one is important because most of the time you will see that the numbers are pretty close, but there might be cases that somebody showed 8 hours and the other one showed 1 hour, right? So that actually needs some discussion, because maybe somebody who showed 1 hour know a better way to do it more efficiently, or maybe there's component reuse, or somebody who thinks it's 8 hours knows some kind of a challenging part that people didn't really figure before. So this is a very important step, because it actually asks everyone to give your opinion and experience on the table, and so that it guarantees a more accurate estimation. And also normally in this case, a common case is some of the experienced guy will probably put less hours, but it doesn't really push the team. It actually really gives the team the opportunity to learn something that maybe some of the junior developer doesn't know. Maybe the new some of the libraries that's already being built there, some of the services they can reuse, or some of the code base they can pretty much use to refer. Pretty simple, right? So that's kind of very important practice, right? So for the hours. And speaking of the hours, I do have another question here. As you can see, this one here, I list a lot of examples, right? This one have 4 hours, this one 2 hours, this one 3 hours, this is 2 hours, right? So you almost don't really see like a big numbers, right? So very rarely you will see, for example, 8 hours. Also very rarely you will see like 10, 16 hours. Or maybe sometimes, when you are doing the project, you think I'm going to need 1 week to do this project. So that task need to be 40 hours, right? So my question is why you mostly see this small number of hours of a task inside the company, and rather than the big number of tasks, like in terms of hours. Any comments here? So why, my question is, for these features you listed like in the slides, it's mostly 2, 3, 4 hours. Why don't you see a lot of a big hour, like a 16, 40, 30 that covers multiple days? Yep. So that's kind of the reasons. Okay, there are 2 reasons. Number one, there's something very interesting you probably don't know. At least for my experience in Amazon, okay, so if you have a task that says 4 hours, that's actually a big task, and then you can almost consider that this task you need 1 day or maybe 2 days to finish. All right, so a lot of teams assume that every day you can only finish a task with 4 hours or a task with 2 hours. Okay, it doesn't mean that this task we just try to put a smaller number. It takes 8 hours, but I just write it to no. When they said 2, it is 2 hours, but we only expect you to finish 1 like 2-hour tasks or 4-hour tasks per day from the team's point of view. And the reason is not because the team has so good benefit that you can just work for 4 hours, 2 hours for the compensation of 8 hours. It doesn't mean that. The reason is that inside the company, all right, coding is not the only thing you do. All right, you have to spend a lot of time on a lot of other random things, such as interviews, such as meetings, such as talking to some of the customers, or having some design meetings, all different kind of meetings. All right, every day you can't spend all the 8 hours just on coding. That very rarely happens. As a junior developer, you normally have more time on coding, but when you go to senior, you have more time spent on meetings. That's why, you know, the 2 hour, 4 hour pretty much represent 1 day's work. Okay. Another reason, just like Lisa mentioned, that when you have a big task, like a 40-hour task or 16-hour task, it's not a very good way to do that way. You should actually break it down to generate smaller tasks. So that's easier to manage, and also it's you know, it's a lot easier to estimate, and it's better to control. So we don't want to see those big number of tasks. All right. So that's the series behind these numbers. But estimating this one is really important. You want to get it correct so that the team can start to work on it. All right. So that's kind of the things I want to share today. But for Scrum, there's still a couple of details we need to tell you next time. So I'll share that one on Thursday. Particularly, some of you mentioned about Scrum meeting, and then also how do we actually document everything? What tools do we use? So we'll talk more about that one on Thursday. All right. So any questions? So for a team project, you will need to use and follow the Scrum approach, okay, to move forward. Getting the list of a task assigned to people, and then estimate the time, have a kind of plan for every week, which will be your weekly sprint, and then go from there. From next week, we'll also do some kind of weekly Scrum meeting. All right, so every team should do some kind of updates in the class. Yeah, so we'll probably ask you to use a tool. You can use GitHub issues, or you can use some kind of external tools. I know there are a lot of options. Yes, it will be good to have some kind of tools there to manage your tasks. All right. Cool. Any other questions? All right. Sounds good. And yeah, so I think I will see you on Thursday, and then we'll talk more about Scrum. Okay. Next time I'll share more practical experience on how do you to be a successful developer inside a company. Okay. Some of the Scrum things are really important. All right. We'll see you next time.